Hello and welcome to the Slackware ARM vlog. With me today is my mate Warwick.
Hello.
I've known Warwick for a long time. I met him at one of the lugs in Coventry. And Warwick has come up to my place today. He's brought me a few gifts. Actually two of which, aren't they? From, what are they?
They're from Spark stations, some Spark stations from back in the 90s, from a time where we even used the like Spark, if I remember.
Yeah. Oh, well.
Yeah.
I still would have had them, but like we were discussing earlier.
Indeed.
It was quite nice to collect old Unix boxes. In the end, they're incredibly heavy.
And expensive.
To run. So we both ditched them all. And then you found these in a cupboard somewhere or something.
Well, no, I found them at my father-in-law's house because I tidied up after 20 years. I took them over there one day back in the 90s. I must have left them there. Or maybe I finched them thinking they'd go in his PC, but they never would. And I tidied them up 20 years later and I found them in his computer cupboard. So I was like, oh, look at that.
And then one of the interesting things about this was this hardware mod here. So you were thinking that this chip, well, actually it couldn't be just that one.
So the chip beneath it has failed somehow, but the chip's too expensive to get rid of. So
why do you think it's failed though? What makes you think that?
Manufacturing defect.
But could it also have been though to just change the behaviour or something?
Possibly. It could have worked, just not optimally, and they found a way of making it work better with a retroactive fix, but it's too late to put it into production. And they've made the decision to do a fix on it rather than bin it, and it's gone out. And the fact that it's done with such neat little green wires in nice right angles is indicative that it was done at the factory and not an afterthought. So that is a manufacturer fix, not a bodge aftermarket.
So I thought that too, and then I posted it on Fosterdon, and somebody looked at it, and when you zoom in, you can see it does look like a bit of a bodge job. But when you look at it like this, or even actually through the magnifying glass, that's pretty dirty actually.
You realise I've been knocked around for 30 odd years.
Well, like you can see, if I show you on the screen, you'll see that the solder is really quite voluminous.
Oh yeah, it's been done by hand. It's not
been done by hand. Oh yeah, for sure.
Yeah.
But you were thinking it was kind of like a pro. You were thinking it was a bit of a pro job because of the way that it bent the wires.
All the wires were nice and neatly done. It's only knocked about because it's been knocked about in my bag and stuff. But when I had it, it was all 90-degree joints. It was done by somebody who'd taken care to make sure it was visually appealing. But it's a dead bug fix. So cool because the legs on the chip point upwards like a dead bug.
That's why it's called that, is it?
Indeed.
So, yeah, I don't know what you're going to do with
those. Museum piece probably belongs down Bletchley along with the other pieces of sun kit that nobody can afford to run.
So, Warwick's also brought this RISC-V machine. Actually, what is this?
This is a Sci-Fi Vision 5.2 from China that I got off like one of these startup things where you pay some money and wait for enough orders that they'll actually build it and then it comes.
Is it like where they'll make a Kickstarter?
Yeah, it was a Kickstarter thing, yeah. It came, I've not even booted it yet, so one of the things that we may want to do if you've got time is have a look at the BSP for it and see if we can get a prompt on it, or at least a bootloader prompt.
Okay. Okay. So here's one of the things Warwick is... I don't even know how to describe your relationship with AI. I'm not sure I have the appropriate vocabulary to describe your relationship with AI.
I'm not married to it. I'm just...
he uses it in ways I've not heard of before.
Yes, indeed. Semantic ways. But it's not to say it's right. I may be barking up the wrong tree for all I know. Time will tell, is what I'll say. But anyway.
Put it this way, whatever guardrails may be in place, Warwick goes nowhere near them.
I'll just smash straight through them. Quite literally.
And one of the things, I'm planning on migrating the bootloader on the Raspberry Pi from U-boot to the native bootloader for a number of reasons. And I realised, we got talking about this, and Warwick just said, why can't you just make your own bootloader? I'm like, well, I'm going to make my own bootloader. So he's got AI to build a bootloader.
Half there. I've got a simple bootloader, fat support. It'll pick a kernel and an RD, stick it where it needs to be. I haven't tested it fully yet. We're yet to actually boot it on some hardware. but the static testing in code to do what it should do as per its design seemed to work. But the way it was designed wasn't to go tell me to build a bootloader. Is I spent a lot of time creating semantic models of what a bootloader should look like, and then told it to build as per the model.
I was quite impressed actually, but I think we should take the
get back to computers.
I think we should actually take it at some point and just put it on the Raspberry Pi and see. The only thing is I don't know what part of the boot. For example, on the Raspberry Pi, the bootloader is in EEPROM. That's the first stage, so it will then boot the secondary bootloader off the SD card.
Yeah, well, that's the bit
but that's split
provided.
into 3 different. There's a number of different binaries, and I don't actually know what they do. I can assume start.elf is the first stage, second stage bootloader.
Well, there'll be a number of named files that it'll be looking for of particular type. So long as you pick the right entry point with the right code, it should work. The amazing thing is using AI to build things that you want just because you don't want to use somebody else's code. It gives you a starting point. I don't know what the license implications are long term. That's yet to be found out. But if you just wanted to jury rig something together to work to get a job done and move on with your life, then it's great.
Yeah. Do you know, it's funny actually, because I wrote I was writing this tool called SARE, which is basically to take the Slackware installer image, and you set yourself up a bunch of triggers that link to the partitions on the image. So like the packages partition, the boot partition stuff, and you write a function that just is triggered if those images are, if those file systems are mounted. Anyway, I didn't want to write the code. So I wrote like the structure of what I wanted, and AI wrote the rest of it, and it was about 30 times bigger than the code I would have written myself. I understood it. I more or less understood what it was there. I understood the intent, but I didn't understand the code. And I was thinking, there's no way I would take a load of code like that and put it in Slackware ARM if I didn't actually write it as part of the OS, because I couldn't think through how to change things if I didn't know how it actually works.
Well, this is it with the bootloader code that I've just written with AI. We've got to sit down there and work through that and make sure we understand it before we productionise it, because you cannot can't ethically use this stuff in production unless you really do understand it. That's where it becomes plagiarism and it's wrong. If you actually generate it on your demand and you validate it, you test it, and you do go through all the assurances and all the design work, like I will look for functional requirements, non-functional requirements before I start writing code. I'll go through the classic processes. Don't skip. Yeah. But if you do all those things, it's valid. You are doing the work. You are pushing it along, asking the question, getting the answer, validating. Is that right? No, it isn't. I'll change that. Yeah, it gets you there a lot quicker. It is lazy, I won't deny. And it is inefficient when it will give you 10 times more than what you need. Yeah. But if you hone it, it is good. And as a starting point, if you don't know where to start, it certainly accelerates your
for sure. I've realised I'm just using it. I'm going to use it now for very small segments of code, like 3 or 4 lines, and just take it and modify that, rather than get it to build. I can 3 or 4 different pieces of logic.
Yeah, I think it's better to use it in small amounts where you can retain full holistic knowledge and understanding of what it's doing.
Yeah, I don't need to know everything, but I can go, I know. Because I was thinking, I migrate from U-boot to the native bootloader. I know how to do it because I wrote all the code.
Yeah.
Or Brent wrote some of it, and I productionised it and took the R&D work and blended it in, so I know how it works, or I know where to look. But if I didn't write the code, I actually don't know what's triggered by what, because I don't really understand what's there. So no one does.
No, well, even I don't know. My starting point for building an ARM bootloader was to ask AI, what does an ARM bootloader process look like? Document the bootloader process, and made documentation to specifications until I got a corpus of information that described the process, and I would go, now look at that, build me a bootloader. Thank you very much. But what I did is I did the requirements engineering up front to specify what it should look like before I asked it to write a line of code.
Yeah, I saw.
How long did it take me? I spend more time doing the requirements engineering than I do writing the code. Because it's so important.
Yep. And the code was generated in a few minutes.
Yeah.
And you've compiled it, so it does compile. Doesn't mean it works, but
no, who knows whether it works. Well, it compiled, but it had stubs for file system support. So although it would have booted something, it had no support for anything to boot from. So you have to go in and, there's the to-dos, there's the bits it didn't do. Right, now we'll build them out. Yeah. But he never told me that those were to-dos. It went, it's all done.
Yeah, you can't trust this stuff. It's sneaky, isn't it? Depending on how busy it is, it doesn't do as much. Wow. It's like people in the end.
Well, this is why me and my friend Anthony call it the Great Lie Machine.
the GLM.
Yeah.
So I know somebody made a RISC-V. I know somebody made a RISC-V port for Slackware. So I don't know what they support, but the thing is, as I was saying to you earlier, if it's anything like ARM, you're going to need to have different, like a bootloader for it compiled specifically for it, rather than just like it's not like booting off EFI or UEFI, where you just plug it in and it's supported by essentially.
There is a BSP for it, a boot support package, but I think it runs Debian, or I think it might be Ubuntu or something like that. I've not actually booted up in all honesty just yet. But from there, you would be like literally transplanting Linux from a Debian system, and from there it's just normal onwards.
Oh, okay. Yeah, so I'm happy for you to keep that. I hope you don't feel sort of offended that I'm sort of rejecting your gift.
No.
Because I'm not going to do anything. I've got an entire. I'll show you later. The drawer, that cabinet is full of ARM 32 stuff. And 264.
Mate, this is a stereotypical ADHD started and not finished project, I'm afraid to say. But I will finish it one day, and it's still pretty cool. I mean,
yeah, they're a good machine. I mean, I've not actually seen one, but the specs look good.
The thing is, you compare it against ARM, and they're both great architectures. The difference is the licensing, and I think that is the thing that will tell as to how ARM Holdings and Co deal with the licenses in the future, or compared to an open model, which is the only thing in recent times that's even comparable to ARM.
Yeah.
So I think they'll cohabit quite nicely. Between the two of them, will definitely be booting some of the older architectures out the door.
Quite possibly, we'll see. Yeah, we'll see.
Well, it's got critical mass on the desktop now, thanks to Apple.
So what does?
ARM.
Oh, ARM. Oh, yeah, ARM. I thought you meant about RISC-V.
But that's the first part in displacing Intel. So I was saying the x86 market.
Oh, for sure. I think I told you before. I wanted to get an Apple M4, an Apple Mini M4, to use as the master build machine for Slackware AArch64 because they're so fast. Oh, it's unbelievable. They're faster than Honeycomb LX2.
Oh yeah.
I mean, and then with the distributing it to the cross compiler on the x86. So I think I've got like 60 cores, 6x86, 64 cores of various different vintages. But that, I mean, plus that.
The advantage is memory speed, because with the Mac, it's basically the same speed as graphics memory.
Is it?
Yeah, because it's shared.
I haven't looked at any of the specs apart from just like the basic stuff. Okay, so one of the things we talked about doing is getting this. So this is one of the original RISC PC, strong arm RISC PCs manufactured by Acorn. This is one of the original build machines that I ported Slackware to over 22 years ago. The other machine no longer functions. You can't boot it because the motherboard is seriously damaged because the battery leaked onto the motherboard and it seriously damaged it, so it won't power on. This machine does power on, but the battery has also leaked onto the motherboard. However, the damage, the blast radius is significantly smaller. But that said, it's still damaged the motherboard, and I don't know. I have to zoom in later on this, but I don't know how. Because the thing is, I had planned to replace the battery with a remote battery. So I want to be able to configure the machine properly with all of the settings and reboot it, because that stands a better chance of the machine booting Linux. But, so in order to facilitate that, I bought a remote battery. But the thing is, I don't know if the motherboard if that's more cosmetic damage or it's actually damaged. So even if we reconnect a battery to it, whether it's going to work. Because I've seen this online, and people have fixed it, but I'm not doing that.
Have you got any isopropyl alcohol to clean
I do actually. Yeah,
well, I'll take the battery off. I'll put some isopropyl on it and find out.
Okay. Yeah, so what we'll do, we'll just start to dismantle this thing. And then the plan is to dismantle this, repair it by soldering on a remote battery, and then powering it on and seeing if we can boot one of the build machines for Slackware ARM that hasn't been booted in 20, yeah, well, at least probably 22 years, maybe 20, maybe 20 years. And I just left the machine, that was it. Just turned off and it was never turned on again.
I've spotted something with this.
What's that?
And I think Stuart may have forgotten.
What?
Count CPUs in it.
Has one. I don't touch it. This is the strong arm.
Yeah, that's a strong arm module on it. But it's got an ARM processor there, isn't it?
Well, it's got the ARM logo on it. It doesn't mean it's.
Then.
This is the strong arm.
I didn't know whether you'd added a daughter board to it.
Oh no, this is where the boards. So you could also have a separate processor here that had an x86. So it actually had a daughter board. I think sort of co-processor.
Yeah. I thought you got strong ARM co-processor on there. No, okay.
No, this is the 233 megs. Yeah. So here, this is where I'd sliced with a knife, a scalpel, through the tracks, and that allowed me to use these dip switches to increase the CPU frequency from 233 to 287.
Cool. Notice that it's air-cooled. There's no heatsink on there.
No heatsink at all, no.
None of it's got heatsinks on.
No. So what we need to do then is take this board out and desolder the battery. Okay, so this is what it looks like. You can see the blast radius of the battery there, and yet the machine still boots. So I'm not going to try and clean this up and repair it because that's just beyond what I'm interested in doing. It's not going to be a daily driver for me, this machine. I just want to boot Slackware on it.
Desolder it so it's no worse.
Yeah. So I think we're going to desolder this and then replace this with that remote battery and just turn it on and see if it works. Okay, so we've managed to remove the motherboard from the case, and the plan is to desolder the battery. So we've got the 2 positive pins here, and then there's 1 negative there. Okay, so Warwick and I have managed to remove this by him pulling on the board, me pulling down and soldering it. So we have the battery.
The Minging battery.
The Minging battery, which we need to responsibly dispose of. Okay, so I have now soldered the remote battery in, and that's all connected up. So all I need to do now is restore this into the case. Okay, so Warwick's working on the bootloader. He's getting AI to build his bootloader. We're going to have a look at that later and see what happens between you and me. I'm not sure it's going to boot. I'm just seeing if the battery has any charge, the remote battery, because I would like it if it did. It has 1.25 volts. What's it supposed to be? Oh, 1.2. Okay. Oh, perfect. Okay, so that means that if it does boot and we can save...
Is 1.2 enough for it though? Does it need 1.5?
Well, this battery came as part of the pack.
Oh, okay.
So
well, is it rechargeable?
It's a pack for this, so it must be...
Okay.
Hang on. Rechargeable, yes.
Oh, rechargeable, that's fine, sorry.
Yes, it does need to be...
Yeah, that's how it always.
It'll blow otherwise, yeah. Okay. Right. I think that we're almost ready to turn this on.
Wow.
So should we plug it into... Can we plug it into the... Oh yeah, plug it into the big TV, I think. Okay, so we have the machine here. We have the monitor, hopefully is still turned on. Okay. So we haven't powered the machine up yet, so I'm really hoping that it still works. Even if the problem with the battery isn't resolved, I hope it still actually powers on. Okay.
Oh, signal.
Signal.
Look how quick it initialises the display there.
Ooh. Oh, okay, it's not going to...
hear that hard drive.
Yeah, I think that's the Slackware one. The thing is though, what's it trying to do?
That doesn't sound healthy. That's like a kick of death, isn't it?
It does have that.
Here you go, let's have a listen. Come on, this is too good to pass by. Oh.
Yeah, that doesn't sound healthy.
There, that's got the click of death, I think.
Yeah. It's not good. Okay, the thing is...
that's got the click of death.
It might not be the Slackware disc. This could be the RiscOS disc. In which case, it's making good sounds now.
Hang on, I've had an idea. Stuart, try putting it in the freezer for an hour. Put it in a bag and put it in the freezer and have another go in an hour's time, yeah?
Well, we don't know if it doesn't work yet, because at the moment it's not booting because it's not configured properly.
Yeah, but if it keeps on clicking, stick it in the in a sandwich bag and stick it in the freezer for an hour and we'll try it afterwards.
Is that a known...
Yeah.
Okay, not heard of that one before.
Yeah.
So what we might be able to do is put it into supervisor mode by resetting, I think you hold down star. Okay, so that's good. So
it works.
We can
ultimately that question is answered.
Yeah, I don't know what all that is.
Pace micro, wow.
No, I mean
so did Pace own RiscOS for a while then?
Yeah, they bought RiscOS, yeah.
Wow, they must have been wanting to compete with like Wind River or maybe what's that other? I know there's Inferno and there's another one that's particularly for comms use, isn't it?
I don't know.
C5 or something like that. Yeah, some microkernel architecture.
Oh, I don't know.
It's interesting they bought it. They must have thought they could do something, maybe set-top boxes or something.
It was set-top boxes.
Yeah.
Yeah. I think they used Ant's what's it called? NC Fresco browser.
Yeah, I guess they found out after a while it was a single user system, weren't really necessarily secure in certain ways, as easy and fun as it was to use.
Well, I didn't know anyone that had one. I never knew anyone that used one.
I saw the one on the internet that they actually did make them and deploy them.
Oh, okay.
I don't know how widely.
Okay.
Yeah.
There it is. Seagate.
Seagate's there.
Okay. Yeah, the problem is I don't know what the... I'm trying to switch to the ATA if it's got stuck.
Home 10.
Oh, no, there we go. Oh, is it? Oh, I forgot it doesn't have the... It doesn't have a... is it string? Okay. Okay, so I've taken the boot disk or the root disk off of the build machine that no longer works, but hopefully if I just put that disk in here, it should boot from it. That's my plan anyway. We'll see how...
box failed via hardware, the software should be good, let's do it.
Yeah. We'll see. I'm not sure it's going to work, to be honest, but it probably won't work. But...
Oh, that looks a lot quicker. You got icons at the bottom.
Okay. Okay. Right, okay. Basically, I don't believe this. So what that means is that hard disk is actually, I think, it can't be plugged into. It should be a standard. I'm puzzled now because I think yeah. So either the disk no longer works properly, or it's actually it's an ATAFS file system off for the ID for the.
Is this that you have to match the disk to the controller?
No, it's not to match. It's not match. Yeah, basically, but just because of the file system that's on it.
Oh, but does the controller detect the file system?
No, the controller. What do you mean?
So, when you use a disk on a particular adapter and you move it to another adapter, can it still read it, or is it particular? Is the format on disk particular to the adapter?
The format, the file system is particular to the.
I thought so. Yeah.
So this has its own ATAFS file system. Yeah. The onboard standard Acorn one is ADFS. Yeah. So it'll be formatted differently.
Well, this is the thing. It's the controller dictating the format.
This is going to be, if we can't get it working pretty soon, we're going to have to call it a night. And this, we have to pick it up another day. But I wasn't expecting it to take this long. Actually, I have to say, I thought it would be just.
Well, it's not complaining that it doesn't know what hardware it's got or the battery stuff.
Oh, that's true. I don't know if the configuration is saving. I don't know if it's persisting because I don't know if that damage to the motherboard is going to prevent.
I don't know, but would it whinge that it didn't know at the start? It should do.
It doesn't whinge about the time, no. It's probably on 19...
Ooh! Get in!
It's not
Healthy.
it's not sounding great, I have to say.
Sounds like an Etch-a-Sketch etching itself a new surface.
I don't think about that because this could be the noise of the destruction of the Slackware ARM.
It totally could
And
be.
all
I'm
of
afraid.
it's like literally it's being sandpapered out of existence.
Is this even year 2000 technology at this stage?
This is what?
Is this even year 2000 technology?
No,
at
this
stage?
is from like 90. I built this in like 94, 5, or something like that. Yeah.
Mate, seriously.
You
I told
upgraded it. It came with
Put that in the
RiscPC.
freezer, mate. I'm kind of half scared it's etching itself a new surface. With a twisted head that's now... I don't even dare dream of the mechanics of that one, gosh.
Well, okay, so the thing is though, okay, even if the build machine, or the build OS itself on presumably this disk,
Honestly, if that's done that much damage on that many spins, it's already...
the build machine or the OS that was broken, I could still, I've got plenty of spare disks, I could still install Slackware because I have I still have the tree, I have the installer, that's all in RiscOS.
Have you kept like the Git trees from back in the day? Do you have it?
There was no, I've got the source tree for it, yeah. It's online actually, I think. Yeah, I think
you
it's
got a
still online.
CVS repo though, is it?
No. There's none of that.
It's a shame they don't have the point in time snapshots to walk backwards and forwards from, isn't it? Really?
Do you know, people say stuff like that, but actually in the entire duration I've done this, for what, 22 years, actually it's more than 22
How many
years.
times you look back?
I don't. There's no point. I just...
Fix forward, isn't it?
Yeah, like really, you don't. If you were working with other people, then you need a source repo that other people could contribute to. But then that just means you're looking at other people's code all the time.
You need known good. You need a history back to known good. But once you got back to known good, you don't need the past beyond that really. But it's nice for historicals. But
what I used to do with Slackware ARM was I'd have. Actually, that's why there were two build machines. That's why there were two identical RISC PCs. Yeah. Because one would be the known good state, and I'd leave it, and I'd start, say, upgrading GCC and glibc, and it would inevitably break, and I wouldn't know what it was necessarily. So I'd have to, because it's like the old days, researching what doesn't work. I mean, like, not a full stack developer. You have to just figure it out. Well, so I go back to there and figure out what it was.
But you just said the two packages that mean the most in any Linux distro. You got GCC and glibc, and then you got the kernel, and your glibc is what everything else hangs off. Right? You upgrade that. Yeah,
exactly. Yeah, you can introduce all sorts of chaos. Yeah, that's why I used to. And bin utils was another one.
Yeah,
break stuff.
I think this is why even on like same architecture, it's easier to cross compile when you're going to do that, even if it's cross compiled as the same architecture, because you know you're going to target a different GCC. Okay. We have some progress.
Well, I don't know about that. Oh. Well, we're doing well. Yeah, kind of. I guess it is. I feel like I really thought it was going to be a lot easier to reconfigure the machine, to be honest. But it turns out that I can't remember. It's been so long. I used to know this stuff like inside out, but
if you don't use it for 6 months, you forget it. But we've got access to the disk.
It's been like 25 years.
There's config. There's Linux. There's a loader.
Okay, so the good news is the disk out of the dead build machine actually works. It's called Moose, and it's down here, and it has the ARM Slack stuff on it. Okay, so in terms of booting it, we still have everything. It's just that the machine isn't actually configured, and the problem is I don't know what I've got the root setting here to be /dev/shdb. Do you remember that HD? I don't know how long ago it was.
That's Linux IDE. That's proper IDE. That's not even SATA.
No, it's not even the SATA. No,
that's pre-SATA.
It's quite old.
That's pre-SCSI IDE emulation.
Yeah.
Remember you had SCSI IDE emulation before you went to SATA.
Yes. What I'm going to do is I'm going to set because I don't know what the
bin share. Oh, the bash. Okay.
Yeah. Right. Okay. So what I'm doing is instead I'm going to try and get the. Oh, hang on. Wait. It's not. Did this not? Oh my God! This is pre-initrds.
Yeah.
This is just the kernel with the root.
No. Where's your initRD?
No, but the problem. No, but there's no.
No, it's slack sys the.
No, that's
root.
just. That's a kernel command line. It's my
okay.
Slackware picked up. I made it pick up on what the machine was. This is like.
Oh, is it hard coded in the Z image? You got a Z image listed there.
No, there's nothing hard coded in it. This is these are kernel command line.
Yeah, I know, but all sorts could be in the Z image. What's in the Z image?
No, this is the kernel. The image is on ARM. It's called image or Z. GZ.
What about the boot?
That's the kernel. So all it's doing really.
Literally, it's just booting off the device.
Yeah, all of the drivers, because it was just for this machine. You don't need an init RD.
Yeah.
So,
but you need to put the root on, otherwise you won't be able to go to the next stage because you ain't got a RAM disk.
Exactly, that's the problem, because I don't know what the IDE value. I don't know what the value should be.
What is it?
Because
look at that. Didn't you have that disk gap that enumerated it? Mate, you've only got 0 to 4 on it.
Yeah, but
it's not rocket science.
No, it's
literally we're 0 to 4. You got 4 bytes to the apple. There you go. Device 2. I'll put menu on this device 2 by that map. Go on, stick a 2 in there.
That would be of course. I'm glad you're here. I would have just doing it a different way.
Mate, I just brought the department to the bleeding obvious.
Yeah, of course, bleeding obvious. So device 0 is Moose. Yeah, that one's empty.
To make it device 0, that's right then.
I'm just confused because...
If device 0 is Moose, that's right.
Yeah, no, I think you're right. Yeah. Okay, so let's change that. I'll just dump this. Right.
It's got a disk, it's got a root.
How do you cut the... Oh, like that. Right, so... Oops.
While you boot this, I'm going to go and have a look at my Mickey Mouse Raspberry Pi bootloader and see how far we got with that. Is that alright?
Do you want to just see if it... Hang on.
I do. Yeah.
So wait, that
Push the button, let's see.
Hold on.
Push the button.
That would be HDA B-C, right? So this should be HDC2.
But it's going to be C or A. It's going to be C or A, depending.
Yeah, it depends on the... Okay. But, we'll figure. It can't... I mean... It's not easy. It's not that complicated, is it? Right, where's on?
At this point, it's just enumeration to find the right. Ooh.
Yeah, this is just the bootloader, but it should be booting the kernel though. You should see the kernel boot because that's on the machine itself.
So does it come up faster than this normally?
Yeah.
Okay.
So I don't know why it's doing that. Hold on though. What if I? Okay, so I don't know what's going on with the bootloader here. I was going to try and get it to boot the installer, but I can't find the installer. I do still have the installer for whatever this was. Slackware. When did I start it? Was it 12? Was it version 13? No, it was 11. Slackware 11, I think I first ported it to.
I don't know, but back in 2000, you were banging this onto Marvel Shiva plug. So what were you running back then in 2000?
What do you mean? I don't know which version of Slackware off the top of my head.
I don't know. When
I did a release of 11 though.
Well, remember when I first met you were putting onto Slackware onto Marvel Shivas.
Oh right, yeah, I did, yeah.
And it would be whatever release was back then around 2000.
I don't remember what release was. Yeah. But I did. But the thing is, it was so slow to do the development that.
I think the main thing was back then it was just you and your own tree and your own device and nobody else bothering to do things. So unless you made it happen, it didn't happen. And when you did it, it affected your world until you got a whole thing where you can go, oh, I've got a thing now. Yeah.
Well, yeah, it was quite a thing to get stuff working. Well, one of my friends, Jim Hawkins, did quite a bit of work on the kernel. Like he ported the driver for, I think he did, yeah. He ported the driver for this IDE card from NetBSD to Linux.
Wow, nice.
So he did that, and he fixed the tool chain. He fixed kernel bugs and stuff like that, and submitted them to Russell King, the maintainer of the ARM tree, when it used to be a separate tree. So yeah, he did quite a bit as well to get stuff fixed because the ARM was not in a good state back then. A lot of stuff didn't build, and some of it didn't even have ARM support. Like for example, MPlayer, I think it was MPlayer. Somebody eventually added ARM support for MPlayer so it could actually work. Grub. That wasn't Grub that it was booting. That was. I think I must have had multiple bootloaders in different directories and stuff when I used to develop stuff and just put them in because there should have been Grub booting. Slackware. I used Grub, not Linloader. I used Linloader originally. Right, thanks. That's enough of that.
Yeah. So we're up
till like 7 a.m.
What have I done with it? Excuse me, one
Warwick's
second.
been hacking on his
Tinkering.
bootloader using AI. He's got it. You're using QEMU in Visual Studio.
Yeah, so using QEMU, I'm using Claude Code and using semantic notation 3 specifications to describe what it looks like before I start, and then I'll try and code it up using the descriptions. We got quite far. We didn't get everything we wanted doing, but if I do a very quick flick on the docs, I don't know if you can just zoom in here, the facilities on here. So we've got a lot of documentation on what it's done so far and the limitations it got to. Just have a look at, trying to find something that's really...
So, which one is it? Is it Claude?
Claude, yeah, so there's Claude Code. Software features.
So Claude has created all the code and all the documentation.
Yeah, I have barely lifted a finger, to be honest.
We're
getting there. We're going through. As far as vibe coding goes, frustrating. You spend 20% of your time making 80% of the product and 80% of your time refining the last 20%. This is the waste of time in vibe coding. But it does get you an MVP. You can get going with it, but it doesn't replace knowing how to code. But you can see there from the number of green ticks of things that it's thought about and implemented, there is a lot there to cut through. But it's all actually driven from what I call my ontologies in Notation 3. So I'm creating lots of different aspects of semantic information around how it boots. And then I collate this and I show it to AI and go, make something that fits this spec. It's right. Requirements engineering. And I'm honing this. It's not quite perfect yet. But I do have varying degrees of success with it, and I have no doubt that if I refine the ontologies far enough, I will be able to get it to automatically generate the bootloader.
Right. Give us an overview of what feature set this bootloader has.
Okay, so well, first and foremost, it boots, which is a start. So you can see something on my QEMU, but we didn't get it on the actual Raspberry Pi. It will read an SD card. It will read FAT12, FAT16, VFAT. It will initialize the basic I/O of the board to get it going. So it's got like the start.s file and how to wire it all up. And to be honest, from there, there's a whole load of other features in there that I had to rack back, but we'll be putting back in. Like one of the things is people make code that does a thing. I like to use finite state machines. So you create a machine to manage the thing that has been done, and then you can track the states, do interlocks and all kinds of safety things. So it looks a little bit excessive, but it's how you do it in like more safety critical settings. Yeah, you wouldn't just assume that something succeeded and move on to the next. You'd have to do assurances as you move between states. So it's kind of done with that in mind, just because I can, and it is overkill, I don't care, it is. But it was fun. And as you'll see there, the last thing I placed in that repository was an AI disclosure document, because ethically, if you didn't write it, you should fess up. Here we go. So we have a command, a couple of commands to issue. So we'll go into that directory. And from there you can see that it's in an idle loop now, so it's effectively started to boot. It's not quite come up to a memory test fail. Okay, but the boot otherwise looks half successful. Yeah.
See, what makes me really wonder is the fact that it came up with kernel 8.image, and that's actually the Linux kernel. That's the default name that the Raspberry Pi second stage bootloader uses if you don't define it. No, not at all. The EEPROM, the first stage bootloader in the EEPROM looks for start something.elf, start 4.elf, or start, depending on the Raspberry Pi model. That bootloader will read the config.txt, and if there is no kernel parameter, it will just pick a default called kernel 8.image. So in Slackware's config, it was called slk zimage, whatever. The fact that AI has decided it thinks it's called kernel 8.image means it obviously doesn't have a clue what that actually is.
No.
Right. So that to me is like, okay, the fact that it's done that is something not quite.
So what we'd have to do to correct that is to go find the documentation for that aspect of booting within the ARM documentation, create suitable Notation 3 documentation on how it's supposed to work, and then regenerate it from the ontologies with that knowledge in there. So I generate my knowledge structures and my code side by side, so that I've always got a knowledge representation and the implementation.
Okay.
And yeah, it's about as correct or as incorrect as I could be, for as much as I know. And to be honest, like doing the network stacks, we wanted it to do TFTP booting, but you need TFTP, you need boot P, you need DHCP, you need ARP, you need RAP. It ain't just TFTP. So it'll tell you that it's done it. Oh, you got TFTP boot. It won't work because you haven't got all the other pieces. But you have to know that.
Once enough.
I'm old school.
Yeah, I used to do sync multiple times. You never needed to.
No.
Right. So let's put the SD card into the Raspberry Pi. Okay. Right. This is the Raspberry Pi's monitor over here. Okay, and we've got serial there. Actually, I'll tell you what. Let's bung the serial on this screen, so then we've got them in one place. Right.
Just want to move your arm out of the way just a second. Just move your boom down.
Oh. I can't. Oh, it's a pain if I do that.
Okay. Don't worry.
It's fine. You don't. Okay. So I'm going to turn it on. See what we get. So this is a serial output. That's the monitor. Don't see anything on the serial.
Nope.
It is actually still turned on though. I assume.
No, it's off. Isn't it?
It should be on. It should just come on when you have a signal. Because the first time we tried it, it did. But then you've renamed the. Is it actually powered on yet?
It is on.
Yeah. So. Yeah, there you go.
The joys of development when you think it's going to work, and you get nothing but a black screen. Oh, to joy! I'm not giving up yet. This is only 1 day's worth of development, and to be honest, what I managed to get as a starting point with an overnight was far faster than what I'll probably do in a week on my own. To be honest, I think it'd have an easier job making an x86 bootloader, but that's only because there's more information out there for it to train on in the first place.
That's enough for ARM though. There's loads of ARM bootloaders. So
totally, but
anyway. Okay, if you made it all the way through, well, thanks for watching. I hope you found it useful. Thanks a lot for your support for the project. Helps buying all this stuff to have fun with and put it back into the community. And thanks Warwick for helping me fix the RiscPC PC. I'll pick that up sometime in the future. Next is working on integrating the Raspberry Pi 5 support into Slackware AArch64. See you in the next video. Take care everyone.
Won't be using my bootloader.
It's not ever using your bootloader, mate. It's definitely not using your bootloader. No. No. Bye.